In this section, we're going to cover the topic of finding area between curves. Because in the previous sections for integration, we learned that when you integrate, you are actually finding the area between a curve and the x-axis. So the question now is going to be, how would you find the area, between a curve and a second curve if I wanted the area just in the middle, right? And it turns out that it's actually kind of simple. It's really kind of simple, because if you think about it in two separate instances, you say, okay, if I were to find the area, let me just call maybe this curve f of x, and I call this curve g of x. If I were to find the area of the curve of f of x, the one that's on the top here, it would give me, kind of all of that, right? But if I set my boundaries to stop right here at the intersection, then what I would get is the area from 0 to that boundary, or whatever lower boundary I set. Now, that's too much, right? I don't want this area here. I don't want this area in there. So what would I do to get rid of that area? Well, if I find the area of g of x, do you notice that is exactly the area I do not want? That is the precise area I need to get rid of. And if I subtract that away, it'll leave me with the area that I want. So just like good old geometry problems that you would have done growing up throughout school, like if, for example, if I gave you a square that was circumscribed with a circle inside of it, and I told you the circle had a radius 2, and I wanted the area, pretend these are touching, I wanted the area of the rest of the square. So if you think about like kind of cutting out a circle, right, how would I find that area? Well, you would say I would find the area of the square and then take away the area of the circle. Well, it's the same idea here. What we're going to do is find the area of our f of x function, and then we're going to subtract the area of our g of x function, and that will leave you with the area we want. So the trick to this, though, the trick is you have to say, the one that's on the top, the function that's on the top is the one I have to start with, and I have to subtract away the one that's on the bottom. All right, so this comes down to a couple steps, but it's pretty logical. You say, I want to find the area between these two curves. So we're going to sketch the graph, and you have to know which one's on the top and which one's on the bottom. And depending on the complexity, you might either graph by hand or you could graph using a calculator. But it will slow you down significantly if you try to use a calculator for everything. Where, for example, if you look at this and say, look, it's a parabola opening down because of the leading coefficient, it's going to look something like that. And notice we're going from the interval 0 to 2, hence why I started at 0. Then the g of x function is a line. It's y equals x. So therefore, it's going to look like that. So now if I want the area between the two, I know which one is on top, which one is on bottom. I need to find the area of my black curve, the f of x curve, and I need to subtract the area of my blue curve, my g of x, not f of x, my g of x. There we go. So therefore, how do we find area? Well, we learned that we can just integrate. And they're telling me we want to go from 0 to 2. So we're going to go from 0 to 2. And my f of x curve is negative x squared plus 6. Then I have to subtract my g of x curve. And I just want to find the area of all of it. So now, before you get going, of course, you can simplify a bit to try to make this as easy as possible. So let's combine like terms. Well, there isn't really much in the way of like terms, but at least I can kind of reorder it and make it look a little nicer. So now this antiderivative, hopefully, now that we're at this point in the course, is not a problem for anybody. This would be negative x cubed divided by 3 plus x, or sorry, not plus, minus x squared divided by 2 plus 6x evaluated from 0 to 2. And what we're going to go ahead and do is substitute in 2, substitute in 0, just like normal. So this would be what? Negative 2 cubed over 3 minus 2 squared over 2 plus 6 times 2. And what do we get? 2 cubed is 8, so this would be negative 8 thirds minus, let's see, 4, 2 squared is 4, 4 divided by 2 is 2, plus 12. And so just working this by hand, let's see, negative 8/3 plus 10. That was the world's worst 10. And if I want to get common denominator, so I could add this, this would be 30/3. So 30/3 take away 8/3 is going to be 22/3. So there you go. That gives you our answer. So what is the big idea? What is the steps? Well, all right, first thing you have to do, you have to graph. You must visualize the graph because you need to know which function is on top, right? You have to know which function is on top. Then once you know that, what do? You are going to find the antiderivative of the top minus the bottom, and then you're done. It's a regular problem. Okay, so let's try one more. Let's find the area between the curves of f of x equals 1/3 x squared and g of x equals 2x over the interval of 0 to 6. Okay, so let's go ahead and graph this graph. All right, let's see. 1/3 x squared is going to look something like this, and 2x will look like a line, right? Something like this. And the question is, do I actually know which one's on top? Well, one way of checking is if you just, well, obviously starting at 0, they're going to be intersecting, right? Because this would be 0 and this would be 0 when you substitute in 0. So therefore, at 0, 0, I know they're intersecting. But do they start off on top and continue like this? And then also, where do they intersect? Maybe the one that is on top switches throughout the problem. And that will come up a little bit later. We'll do one of those. So how can I verify which one's on top and where? Well, what I can do is find the intersections. And how do I find intersection? Just set them equal to each other, right? Set them equal to each other and solve. So therefore, if I move this over, if I say this is minus 2x equals 0, so therefore I could factor out an x. So that's going to leave me with that. So what do we have? We know one intersection is going to occur at x equals 0. And I know the other intersection will occur at 1/3 x minus 2 equals 0. So if I add the 2 across, multiply by 3, that gives me x equals 6. So as you can see, maybe the person who created this problem picked 6 for a reason. Haha, because we don't have any switching. So I'll give you one guess what will happen in the next problem. Anyway, so therefore we know the function that's on top to begin with will remain on top until the value of 6. So if you kind of just think about picking any value, like for example, I picked the value of 1, f of 1, and I plug that in, I'll get 1/3 here, and g of 1 equals 2. So therefore, my g function has a y value of 2, which means it's higher than a value of 1/3. So therefore, my g of x function, my red function, I'll write it in red, my g of x function is on top from 0 to 6. And then we can see from our sketch, after that, it would now be on the bottom. And again, you might be saying, why is that so important? We'll get there. But for now, we just know we have to integrate from 0 to 6, and it has to be the function that's on the top, which is g of x, minus the function that's on the bottom, which is 1/3 x squared. And we do that integration, and we will get the area. So here we go. Antiderivative of 2x would be x squared. Because the 2 would be dividing by the 2, those would simplify. Minus, let's see here, this would be x cubed over 3 all times 1/3, all integrated from the values of 0 to 6. So let's see here, what does that leave us with? Just simplifying before we plug in our values, that would just be x squared minus x cubed over 9. Going from 0 to 6. So now I'll put this kind of off to the side. So here we go. Let's substitute in our values. So this would be 6 squared minus 6 cubed divided by 9 minus 0 squared minus 0 cubed divided by 9. And the good news, this whole part goes to 0. So we're just looking at this part. So what would that end up being? Let's see. This would end up equaling 36 minus, now I'm going to cheat a little bit, I'm going to rewrite this as 6 times 6 times 6 over 9, or which is the same thing as 3 times 3. And now I can kind of do a little cheating, because 6 divided by 3 makes 2, 6 divided by 3 makes 2. So therefore, what do we really have here? We really have 36 minus 2 times 2 is 4, 4 times 6, that's 24. And so that gives us 12. All right, so our area is 12. Fantastic. All right, so that is the basis of what we're doing here. I'm going to go ahead and stop this video, and we'll pick up the more advanced techniques in the next video. We'll see you then.